Good morning, everybody. My name is Jessica Molina, and I am the Business Development Manager with Avalon Test Equipment. Today, we are going to be presenting you a webinar on exposed solutions on resolving RF interference and PIM with high RSSI RTWP issues via CPRI testing. And I have with me Danny Slayman. He's the Business Development Manager for Expo, and he's going to be able to provide the presentation today for you guys. As far as for questions, we will have Q&A at the end. There is a Q&A button that you guys could be able to enter your questions along the presentation, and then we will be answering those at the very end of the presentation. Danny, can you go to the next slide? All righty, so let me tell a little bit about Avalon Test Equipment. Avalon Test Equipment has been around for 25 plus years. We are known for our rentals, and we offer rentals on a variety of different brands and manufacturers, including Expo Solutions. Besides rentals, we also offer lease to own and sales as well. We are also the home of the 24-hour calibration house for basically almost all major manufacturers, to include Expo here in the US. We also do, besides calibration, we also do repair services as well. So we do have a lab in San Diego and in Dallas, Texas. We also can do on-site calibration if that's something that you guys do require. You guys will have our contact information at the very end of this presentation, but just know that we do offer those type of services. As far as training, we do offer basically monthly webinars to support our different manufacturers that we support, that we sell their equipment for, that we rep. And so we always provide educational webinars, but we also do have training sessions. And these are some of the training sessions that we have currently available. And if you guys have any questions about our training sessions, you guys could definitely give me, you guys can send me an email afterwards. My contact information will be at the end of the presentation. So I will go ahead and give it to Danny so he can go ahead and start the presentation. Thank you, everybody.
Thank you, Jessica. Good morning, everyone. So today in the webinar, we'll be talking about resolving RSSI and RTWP issue. The webinar is really divided into threefold. And the first is going into the impact on the network, resolving the issue using the RF over CPRI, and how to quickly pinpointing the source of PIM. So before we start, what we did in the past months and years is that we did some survey with customers, and we talked about the most common issue impacting the network performance. So to give you a kind of a perspective here, when we talk about network maintenance and troubleshooting, whenever you have a site down that's not functional, this is going to be really key to resolve as quick as possible. So you can have, for example, fiber issue, you can have SFP issues or radio issues. Now, once you look at those, that's key because it basically needs to be resolved as quick as possible because your site is not functional. Then comes, backhaul issue. It could be broader issues where your site is not communicating with the core network, and at this point you have SLAs from network fiber providers and from different people that basically are giving you that service to your network. Now, today we'll be touching a lot on PIM issues and interference. That's going to be the main focus. But as you see them in the list, they're in 5 and 6 position. However, what we saw with time is that the more you have impact into PIM issues and RF interference, the more the importance come up. And that's what we're going to be talking about, and why this sudden surge in the past few years of PIM issues, and where does it come from and how to resolve it. Additionally, when we look at 5G networks, basically with new bands like C-band, millimeter wave, there's a lot of TDD out there. And the thing with the timing issues is that they're really more dominant when it gets to 5G. So that's why it's at the last. Not a lot of people are focusing on this right now. However, we see a trend where, those timing issues could be increasing with time. So really in this presentation, we'll be going into those PIM issues and RF interference. But first, let's try to understand what is PIM. So to put it in perspective, this is a bit more technical slide, but I'll try to make it as simple as possible. When we talk about PIM, it's passive intermodulation. It's really the generation of interfering signal. And to make it as simple as possible, it's really when two signals mix together to a nonlinear device. So what we mean by nonlinear device, those are things we will see in the coming slides, where it could be rusted metals, it could be devices or places on your site that are causing this. And when we look at that, take two frequency, F1 and F2, let's call it that way. And basically, by simple math calculation, it gives you harmonics which are located at different location. Now, if we put that in perspective, if we take 700 megahertz signal and a 900 megahertz signal, you will have harmonics that are falling into the 200 megahertz and the 1600 megahertz. So if you do have a signal, for example, an uplink signal at 1600 megahertz, doubtly that you have something at 200 megahertz, but at 1600 megahertz, that might cause an impact. Now, this is just a generic, calculation just to show you. We'll show you kind of the impact of adding new frequency band with an example of an operator in the next slide. Additionally, on the internet, you can find PIM calculators. So the first step always is, if you doubt you have PIM, you can always use a PIM calculator to make sure if you do have harmonics that are falling into your uplink band. Now, let's take a look at the impact of new frequency band. So if we look at it, this specific operator has two signals that are running downlink at 700. Then they added the LTE 800 downlink. This is the F1 and F2 that we saw on the other slide. And when you do the math, it gives you a third harmonic that falls directly in the uplink of the 700 and also directly in the uplink of the 800. So this kind of, passive intermodulation, what happens there is that the addition of one band impacts your new uplink and your existing uplink. Now, when you look at this graph, we made it as simple as possible, so so everyone understand in terms of third harmonic and intermodulation, this size of the interference could be very narrow depending on where it falls, but also it could be wider band. So the idea here is that if you do have a third harmonic that falls really in the center of your uplink and is impacting 5, 10, 15, 20 megahertz, while your signal is either not going to be accessible, or users will be able to connect but not be able to basically receive data. They will have a hard time to having calls. Now, when we talk about PIM, we talk about the third harmonic. Very technical, but there's different type of intermodulation that can happen when you look at your PIM issues. So your third harmonic will be the one that's impacting the most your network. Then you can have a fifth order, a seventh order, which still can impact your network, but not as much as your third harmonic. So that's why when you use calculators and when you start to looking around, um, you're gonna know directly on your site that you're testing right now. If you have frequency A, B, C, you can have PIM that is affecting basically the uplink on those. Now, what's really key here is basically this PIM, and depending on where it falls, how it impacts. So we were looking here at band 14, band 17, where you have PIM, a different example. What's the impact on the network? Well, first of all, your noise level is going to increase, which is going to generate a loss of coverage for which is really impactful. We're going to see that in the next slide. But the idea here is that your KPIs are affected. So you get RSSI readings. In certain cases, certain operators are using not RSSI, but RTWP. So you get those high RTWP KPIs that are monitored there and that they're saying we have an issue. So when we look at the network KPI, I would say the higher the impact of PIM, the more you're going to lose coverage. But we worked with operators to kind of put it onto a graph so we could visualize this and see what is the consequence of PIM. So if you take a normal operating site, which is currently, for example, minus 118. I know certain operators could be a touch lower, but a lot of operators also are a touch higher. So minus 118 dBm, which you have 0 dB of PIM that is impacting. Now take a 6 dB impact due to PIM. This impacts the coverage from 50%, and you can see it here very quickly. So let's say your coverage is this this green circle right here, and then you look at your yellow circle, so you're impacting 50% of the coverage. And now take a 9 dB PIM, and now you're impacting 75% of your coverage. So let's say you have devices that are located right there, they're trying to connect, they won't get access, and same thing when they try to go out of, they get further to the site, they will have either a drop call or they won't have connection. So really PIM impacts the network coverage, it impacts the quality of service, you get unhappy customers. But you see here dollar signs, because the idea is that operators are paying for this frequency bands that they're using. They're installing new sites, which cost a lot of money. And the more you have impact on the coverage, the more it has a cost behind it. And that's why today we see those PIM issues needed to be resolved as quick as possible. Because if you don't correct that, we saw in certain cases the adding new cell site, temporary cell site to improve the coverage. So all of those PIM issues need to be resolved as quick as possible, so the network coverage comes back to closest to 100% possible. Now, when we look at PIM, there's different types of PIM, and when we say different, there's external PIM and internal PIM. So an external PIM is anything that's outside of the antenna radio system, and an internal PIM is really from the antenna to the internal side of your site. An external PIM, and as we were saying earlier, those could be rusty metal surfaces, it could be galvanic corrosion, it could be loose mounting brackets. Let me explain the loose mounting brackets. If you do have a loose mounting bracket, you're going to have a space. So this is metal to metal, and you have a space in between. What happens when those two frequencies are transmitting? They're going to hit that gap in between the two, the mounting bracket would be basically between the two metals. And it creates that third harmonic, which is really going back to your uplink of your system. So the idea of external PIM is it could be anything that's surrounding your antenna. And we learned with time that this could be in the front, on the side, and the back of the antenna. It's not necessarily just in front of it. When we look at internal PIM, I would say this has been there for a long time, but the more you add site, the more you have chances of having internal PIM because of the amount of coax that we're adding, the amount of antennas that we're adding. So this could be first the antenna that's defective. Um, you can have a loose RF connector, as simple as that. This wasn't torqued correctly or detorqued with time. You can have metal shaving or dust directly into the connector. Additionally, you can have, some cables that are broken. The idea here is that internal PIM, as soon as we think about it, the first thing we think is, oh, let's replace the radio. Well, that's what we want to stop doing, because in the past, when you had maybe one or two antennas on the site, and you had basically a simple installation, you would replace the radio, you would see, okay, so did it fix my issue? Yes or no. It could still be the issue, the antenna or the radio. However, the idea is that with this multiple of PIM issues that are popping up left and right, if we start replacing all the radio, there's a cost and it's not fixing the issue. So that's why we need to look at it as, okay, so is it internal, is it external? Then it's going to give us different point of action. So when it's internal, as you're seeing in this picture, we might want to look at antenna, connector, and the radio ports. When it's external, we want to look outside of that antenna. What's transmitting? What's around there? How the site was installed? And last point I would say on the external PIM, what we saw a lot is that you had old sites where we added new bands and new radio, new equipment, and those old sites maybe weren't installed as good as the new one are installed. So a lot of operators are looking to resolve those issues. They're working with contractors, they're working with PIM experts trying to resolve. So we're going to talk about the CPRI method. But before we go into detail, what's really important is that when you look at internal, external PIM, and there's still external interference that could be out there, there's a sequence that needs to be followed. And it's important to follow that sequence because when you have an issue of RSSI or RTWP issue, if you don't follow this sequence, what's going to happen is that you might be resolving an issue that's not impacting your network or not the one that's impacting the most your network. And this sequence is very simple. It goes from 1 to 3. So if you do have an internal PIM, this is the first thing that needs to be resolved. Internal PIM are going to have the highest impact to your network. And let's just say, for example, we have a case where we have an internal versus external PIM. Well, the internal PIM needs to be resolved as quick as possible because sometimes the external PIM issue might not impact your network as much as your internal PIM. So once we resolve the internal PIM, then we take a measurement and we see, okay, so I still have a big impact. I need to resolve it or I don't need to resolve it. And lastly comes our external RF interference. RF interference, as we all know on this call, it could be a multitude of devices that are in your houses. It could be repeaters, it could be TV amplifiers. But when we look at the external RF interference, the impact on the network is kind of the least in there. So if you get on site, your radio is good, your cables are good, so there's no internal PIM, no external PIM, and your RSSI is still very bad, well, this is where you get to a point where you want to resolve the RF interference. One of the major challenge we saw is how do we determine if it's internal or external? And when we look at it with the traditional methods, we used to use PIM analyzer. We'll get into that and there. And PIM analyzer are still key, and they're still great devices to determine internal versus external PIM. But however, with the addition of new cell site and you're talking a site that basically had 2 bands and now could run maybe 5, 6 bands. They needed a way basically to identify this challenge as quick as possible. So how do you go basically in knowing if it's internal or external? And if it's an internal, if it's for example, a tower, you're going to need a tower crew. If it's on a rooftop, maybe you have access, maybe you need, specific people are going to do it. And if it's external, you need to hunt and start looking for it. So we're going to touch on how to resolve those issues using the RF over CPRI method. So working with Avalon, working with ConcealFab, working with Keyless, we created the improved PIM hunting process. This is, there's a lot of details in here, but I'll invite you to look at 2 specific things. So you see here the PIM analyzer method and the CPRI analyzer method. So the idea is that you get your triggers, your high RSSI, RTWP, and then it is sent to a team. And the first thing we're asking to do in those 2 methods when you follow this is to use your eyes, look around. Is there something specific I should see? Is there loose connectors? Is there metal to metal touching somewhere? So first analysis that needs to be done. Once this analysis is done, and for example, you can resolve some small issues here and there, but that's not enough. Then we're going to start using the CPRI analyzer method. And to show it to you here, this is what we're going to do. We're going to try to locate the PIM using the RF absorber. So we're going to put that on the antenna. Then we're going to try to find if it's internal or external. So the goal of this webinar today is to get you to determine if it's internal or external, and if it's external, how to find it as quick as possible. With this improved PIM hunting process, the idea is that if with this we can solve 90% of your PIM issues, and as we saw earlier, the main challenge was determining if it's internal or external, we're going to save you a lot of time into troubleshooting your sites. So first, with the CPRI method, for those of you who never seen it, the way it works is that we need to connect to the cell site. Now, if you used the PIM analyzer before, we would disconnect the coax jumper, plug in to port 1, port 2, port 3, port 4, and go on like this. With the CPRI method, we're going to insert a tap in the fiber between the BBU and the RH. Certain sites have optical splitter that are installed. The idea is that once you insert the tap or you get a copy of the signal, we're going to connect it into the RF spectrum analysis over CPRI. So this is an important difference to make when we do that, because it's not disconnecting or turning off the site for a long time. We're just disconnecting to connect the tap, and then we can bring it up and we'll show you what you have access to. So before we jump into the detail, working with the industry experts like ConcealFab, the idea is that we put a list of what's the advantage. Why would you use such a method to resolve PIM issues? So when you're connected using the CPRI method, you are using the actual PIM sources that are exciting the sites. What do we mean by that is that if you do have an external PIM, when you connect your site using CPRI, you're going to see how your PIM sources are affecting your site directly. There's no need to disconnect the RF connection, so there's less chance to introduce new PIM. So we saw basically when you had the metals that could go in the connector, the dust, every time you disconnect, you have a chance of not torquing completely or introducing new PIM issues. And the site remains operational. So only when you enter the tap for a few seconds, you're going to lock your sectors, put the tap on lock. However, it remains operational. And that gives us an added value because all the antenna ports from all the bands are active during testing. So what I mean by that is that, as you saw at the beginning, you need the multiplication of 2 frequency to create that third one. Now, those are self-generated. Basically, this is the choice of frequency that you have on site. For example, a 700 and 800, which leaks into your uplink of your 700 and 800. And when we look at all the antenna ports and everything is active, you're gonna have basically the same reaction to PIM that we're gonna be able to see on the CPRI analyzer method. When you do improvements, when you change something, all the improvements are going to be reflected directly onto the CPRI analyzer method. And very quickly, because we're seeing all antenna ports, before you had to go port 1 to port 2, then you start to see, do I have PIM on port 1? Yes, no, then you go on the second one. You're able to detect internal versus external PIM in a few seconds. Lastly, everything that's done on site, every testing results will directly contribute to your improvements or your KPI. So the idea here is that we want to know what's impacting our site. So by tapping into the fiber, we're able to see the spectrum, we're able to see our RSSI performance, our PIM issues. And if we do improvements, it's going to directly reflect. So putting it in perspective, you might get on a site, you have 3 PIM issues. You troubleshoot it, you see an external PIM, but you have 3 sources of PIM. Now, fixing all 3 has a lot of cost, but if you fix maybe number 1, that's enough to improve your KPIs to get back to green. So that's the idea of using the CPRI analyzer method, is that we're going to look at really what's impacting your network and really resolve only what's needed to get to a point where you get a green KPI, so the RSSI is good. However, we saw one big challenge with CPRI, and this is where we've worked with the operator, and I'll get into this. The idea is that when you're in CPRI, what you see here is that we're connected into the fronthaul CPRI fiber right here. This is not an RF signal as it is. It's not like a coax. It's not. So it's really digital RF, which is ones and zeros. And when you wanted to look at your CPRI signal, you needed a way to configure this, and this is where it got complicated, and I'll explain this in the coming slide. But with Expo, what we did is that we worked with the operators, we worked with the vendors to make it auto-detect. Oops, sorry. So you don't have basically to go and start configuring every port, every antenna port. And in this example, I'm showing you have one antenna that has 4 ports. But in a lot of times, and on those 4 ports, you can have dual band, tri-band radios, and every time you add a band, you're adding probably 20-30 minutes of configuration to do that. So we'll show you with Expo, we created this auto detection, which basically helps you connect to any sites, whether it's a single band or a dual band, and it's going to be detected automatically for you. Now, once we have access to the spectrum on the CPRI analyzer method, we're going to be able to see all of the branch directly visually, basically using the spectrum or getting PIM values and RSSI readings. The idea there is that since those ports are separated, but they're connected to the fiber, we see all of those ports separately, we display them separately. So the advantage of that is that if you want to determine if it's internal PIM, external RF interference, or external PIM, it makes it very quick. So I'll show you. When we look at internal PIM, it's basically when you have at minimum one port that is affected. So if you have one port that is affected, at this point, as we were saying, could be a coax, could be an antenna port or RH port. So you'll have basically a reading here that says, oh, I have 9 dB of PIM, and now I can view and analyze all the radio ports and see how it's reacting to it. So the idea here is that quickly you can determine if it's internal, external, or external RF interference. Now, one question that I often get is using PIMizer, I could do load testing. What is load testing is basically disconnecting the coax. I know I have an internal PIM on port 3, disconnecting the coax and put a load just to see if the issue is coming from the antenna, from the cable, or from the RH. So you're able to do this on load testing, the load testing on the CPRI. Obviously, for safety reason, you would lock your site for a few seconds, install your load. And once you install your load, you're going to see that your PIM is going to disappear directly on the CPRI analyzer. Now, when we look on external PIM, at this point, it's 2 or more ports that are affected. What we mean by that is that basically, since we have access to the ports separately, when we saw that 2 or more ports are affected, then it's kind of announced as an external PIM issue. Not to repeat here, but could be faulty loose insulation metal pieces. It could be design issues. We've seen that a lot where the way the site was designed, RH placed in front of the antenna, there's could be a lot of things when it gets to external PIM. With Expo, also we give you an indication in the analysis that we see an internal or external PIM, and you'll be able to start troubleshooting. Lastly, with this CPRI method is that we can see if it's an external RF interference also. So the idea here is that before you would get on site, there's going to be maybe a few hours to start troubleshooting, determine if it's internal, external PIM, then you start hunting. With that quick connection, which is very quick, you're able to see if you have an external PIM, an internal PIM, or an external RF interference. So you know what's the next step that needs to be done and how to resolve it as quick as possible. On this, very quickly, you're going to see here that what I was saying earlier is that we detect automatically the IQ data. So the IQ data is what's going into the CPRI fiber, and it's going to give you a site configuration. For example, it's going to give you, we saw 4 ports, 10 megahertz. Then when you hit on start, gives you the analysis. And from there, if you are, for example, a user that doesn't have much experience into PIM, you can get a report out of it. You can see the analysis. You can send that report to the expert. And if you need to isolate PIM, like for example, as we were saying earlier, if you need to do load testing, this is where you can start going into the live view and start seeing your spectrum, how it is impacting. So this gives you a first overview of the CPRI analyzer method, but let's talk about how to isolate PIM. So let's say you have internal versus external PIM. And I brought back this slide just for a few seconds, just for a reminder if people joined us recently. An external PIM is anything that's outside of your antenna, and an internal PIM is really what's from your antenna to your system. Now, when you look at isolating internal versus external PIM, this is a little bit the process that we're going to go through. So first, we lock the sector, we connect the tap, and we install the RF absorber. So the RF absorber is what you see here. It's from Conceal Fab. They created kind of a envelope for the antenna where you can put that directly onto the antenna and determine basically using the RF over CPRI to see if our PIM, external PIM if it's internal or external. To give you an idea, when you put the RF absorber and you look at your CPRI analyzer, if there's an external PIM source, this will disappear once the RF absorber is installed. However, if it's an internal PIM, the issue will be the same or more powerful. So you get the RSSI ticket. You get to your site. You plug in your tap. You look at your spectrum. You see that you have, for example, an internal PIM. Once you get closer to the antenna, put your RF absorber, confirm that. And if it is internal PIM, you start resolving. However, if it's an external PIM, there is a PIM hunting process. And the idea here is PIM could be anywhere around the antenna. It could be in the front, on the side, and the back. So using the RF absorber, the way it's designed, you can basically remove the back, the sides separately. So you can start kind of getting a sense on where this PIM issue is coming from. And PIM sources really could be anywhere around the antenna. So you first start removing those PIM sources, you get an indication, okay, it's not in the back, but could be on the side because I see my level going up on the CPRI analyzer when this happened. So you get a sense on where this PIM is coming from. Once you've done that, okay, so you identify your direction. So do I need to look in the front, side, or back? Now you can start using a PIM blanket, and your goal is to reduce the RSSI level by identifying that PIM source that's going to improve your network and is going to bring you back to a green level. So once you take your blanket, you put it onto your PIM source, you can see your level. You can see it here clearly. This is an animation where we have a site that's very impacted, and when we cover it, and then the level goes down. So this could be one single PIM source. Sometimes you need more than one blanket because it could be multiple PIM sources. But your goal is to get to a point where, for example, I'm at minus 118 at normal. Now I'm at minus 100. I have basically a RSSI impact. It's very high. I need to improve by 18 dB. So you get to your site, connect your CPRI analyzer, and improve by, if as soon as you get to that 18 dB, then you're good to go. You know your source, you can start fixing. Um, so, and one thing that's very key, and that we worked with operators, with ConcealFab, with everyone, with Avalon, and the idea is that the action taking on site with the CPRI analyzer will improve your RSSI level that you see on your site. So really every dB that you gain there will reflect into your network. I keep emphasizing on this because in the past with the traditional method, once you plug in and you start your PIM, external PIM hunting analysis, your level of finding is going to be very high. So you're going to find all the issues around the site, not necessarily the one impacting your site. And that's kind of the idea where we want to stop doing, to stop kind of to reduce the cost and really focus on the issues that are impacting your site. So when we look at the PIM hunting process, with that process that I was showing you, in very quickly, in 5 iteration, you can kind of get a sense, okay, I fixed my issue. While with the traditional method, you're going about 13 iteration of like keep on finding, I find another issue, I go another issue. And we calculated kind of the mean time to repair this. It's about 55% improvement. So tell yourself that for every site that you're repairing today with the CPRI analyzer method, you can probably repair 2 sites. So that's kind of the idea what we want to get at. However, if you don't have an auto analysis, an auto configuration, it's going to take you a lot more time. So that's where Exfo come in and really helps you in terms of the mapping configuration. So we'll look, when we look at this table, just to give you an idea, traditional RF over CPRI method, and us included, because in the past, basically we had our traditional RF over CPRI, which now we added the IRF. So every time you needed to configure, for an expert, it would take them 21 minutes to configure a single band radio. Now add the dual band, you're talking 40 an hour, basically just to configure your site. There's a lot of steps. It's manual. So with IRF, what we're giving you is 15 time saving. So in under 2 minutes, you're going to be able to any skill level user, zero configuration, really get a results. You're going to have your configuration done, and you're going to know if basically if it's internal, external, if it's an RF interference. This is where we basically bring the added value to you. Because always the challenge, even when you use the traditional method, is how to configure the right frequency, how to configure the right mapping. So we really work hard to get to a point where any vendor, any site you're going to connect to, you're going to get that. Additionally, what we do a lot is work with you on the call, whether you're an operator, a contractor, anyone that's working on troubleshooting and maintenance, and we build workflows, and we have MOPs that are ready. So at the beginning of the call, I was showing you the step 1 to 4, where you have fiber issues, SFP issues, that similar to a P2 ticket. We do build those MOPs, and the goal of MOPs like this is not to use expo equipment necessarily, is to how to get you to resolve this issue as quick as possible. So what I mean by that is that if the first thing that you need to do is turn off the breaker, as simple as that, and turn it back on, we're going to tell you this. Once you get to a point where you need to use a test tool, you'll have a link where you can access videos, you can access quick getting starting guides, so we get you to resolve those issues as quick as possible. The P3 tickets that you see here is really the PIM, resolving the PIM issue. So really goes into, you get to your site, you do a visual inspection, you connect your CPRI analyzer, and now you start troubleshooting, and how to go to get to a point where you don't have to return this to the site. Our goal today is to resolve RSSI issue, RTWP issue, but with the least amount of site visit. And our goal is to get it to hopefully to one visit. You get to the site and you're able to resolve. So this is what we worked, in terms of workflow with the operator, with contractors, to get to a point. For those of you who don't know Expo, we do have what we call our FTB 5G Pro. And it does much more than just RF over CPRI. So you can do, for example, RF spectrum analysis. So if you need to install a PIM probe into your unit, you'll be able to do that. You'll be able to hunt for RF interference. We do have our core tools. And when I say our core tools, Expo really started in fiber optics. So we have all the fiber inspection, fiber characterization with the easy link mapper, where you can see all the issue that's happening on your fibers. Multi-protocol testing also is part of it. So what we mean by that is that with the same modules, same as you're using for RF or CPRI or RF spectrum analysis, you're able to do up to 100 gig CPRI analysis, Ethernet analysis. I touched also at the beginning about timing and synchronization. So if one day you get to a point where timing becomes more critical, you'll be able to validate 5G timing, 1588. Lastly, one key thing here is a lot of time we see transceivers on the radio that are not functional, that are not inserted correctly. So with the FTV 5G Pro and our solution, which is iOptics, you're able to validate those transceiver, whether they're SFP or QSFP. They can support multiple interface and speeds. So you plug it in, you put a loop back, and then it goes through analysis. So the idea here is that with this solution that we're proposing to you, basically to do RF or CPRI and to troubleshoot your issue as quick as possible, you can do a lot more. But to go to the next slide, I'm going to invite Jessica to join me so she can talk a little bit about the promotion going on.
Thank you. Thank you so much, Danny.
Thank you.
Hello, everyone. All right. All right, everyone. So right now we are having a promotion on the RF over CPRI solution for Expo. This is tiered for RF over CPRI testing, but it is upgradable solution for anything network, fiber, or analyzed test requirements. So the value to have an all-in-one box for any future requirements is very, very beneficial. So this solution is upgradable. Right now, we do have this solution in stock, and we have this is our sales price, but we also have lease to own options or rental options as well. So please feel free to reach out to us in regards to that as well. And then this is when the promo does end, June 28th, 2024. So if you're working with an account executive with an Avalon test equipment, please feel free to reach out to them. And this deck, I know that some of you asked earlier, will be sent to you guys within 24 hours via email. And also, if there's anything that you guys require for calibration or even repair services on any Expo solutions, we are their calibration and repair house here in the US.
Thank you, Jessica. So I'm going to bring you to the next slide. And
all righty. So here we have, I just wanted to go ahead and let you guys know that this is the contact information if you guys want to reach us for any questions, or if you guys want a quote request, you guys can definitely email us at sales@avalontest.com. We also have our phone number here listed. We do have offices in San Diego and Dallas, Texas. However, you could always look us up at our website as well. That is also here. So what I will do right now is I'm going to open up for any questions that anybody may have for Danny on the resolving RF interference and PIM.
so, Jessica, I see a few questions already. So
Okay.
there's a first question. What does TIMO RTWP stand for? So the RTWP is received total wideband power. That's the acronym. That's what it means. But to give you a perspective, when you get RSSI readings, you get really the average of the site. It's measured. You get a high reading. When you look at RTWP, the difference is that they look for imbalance between branches. So they try to see, okay, if I have branch 1 and branch 2, which has a peak of 5 dBm difference, then that's the flag that it goes. So it's just a different way of monitoring it. At the end of the day, the user or the ticket is going to come in as you have an impact, or the network is impacted and it needs to be resolved. But we saw a lot of times that this RTWP is used basically as a newer way of doing things. I see another question also. Does the X4RF work with all technologies at T-Mobile? So yes, the auto detection works with the vendors that you have in the T-Mobile network, and we tested it with all the different bands and everything. So it works flawlessly. I invite you to try it, and you're gonna see the advantage and the power of it. Lastly, and maybe Jessica, you want to take this one. Does Expo offer hands-on training for this tool, RF over CPRI? So we do, but I don't know, Jessica, if you want to talk a little bit about the Avalon training that.
Okay, yes, definitely. So we do offer training on various different solutions. A lot of it is located at our San Diego or Dallas location. So we do offer a hands-on training in either one of those two locations, or we could also do it remotely at your location. So we have a lot of techs on call, and they're available at any time for in-person training or just even WebEx training if that's what you guys require. I think there's somebody with the hand up if you guys want to put that question in.
Yep. Oh, I see you answered about the presentation. Please, for the hands up, I don't think we have a way of unmuting. So please, if you can use the Q&A button that's on top and just put your question there. So there's a question, Jessica, is any training planned for San Diego or Dallas right now in the coming weeks, I guess, or months?
So I can definitely check back with my team on training. If it's specifically for this solution, I know we have a few trainings going on, but it's for other It's for the RTWP and for other solutions that we're offering as well. But we can definitely look into it and get back to you guys via email. So please feel free to email us at sales@avalontest.com for any of those questions regarding training, and then we could basically tailor it to your needs.
Okay, I think we answered all of the questions. Yeah.
All righty.
Want to close the
Well,
session, Jessica? Yeah.
Yep. Well, thank you very much, Danny. Thank you everybody for joining. We're going to leave it up and running for maybe one more minute just in case anybody else has any other questions, but you're free to log off at this time. Thank you so much.
Thank you, everyone. Thank you, Jessica.